Hello and welcome to lesson 1 of week 4. In this lesson, we are going to look at the outlier detection in Pandas and the different ways we can detect outliers and the different calculations out there to see what outlier exists, and then we'll see how to visualize outliers also. Now, first of all, what is an outlier? We saw last week how we can clean messy data, and we talked about outlier but not go into the details of the calculations of an outlier. We have several ways with Pandas, and then we also have a way we do that with Numpy and how we can use a Boxplot to detect outlier, and we're going to see that in this lesson. Now, an outlier is a data point that significantly differs from other observations in a data set. Now, when we have outliers in a data set, it might be due to data entry errors or measurement errors or natural extreme values or based on rare events, and they can distort your analysis, especially the mean, the standard deviation, and the regression models. And these mean, standard deviation and regression models are things that we use in our analysis to be able to replace missing values and to be able to look at the overall statistics of the data that we have. Now, the mean is like a measure of the central tendency that represents the average value of a numerical data set. So when we use the mean, we use it to summarize data, especially for symmetrical distributed data sets. And when we say symmetrically distributed data sets, we mean the data sets where the left side or the left and right side mirror each other around a central point. So it often forms like a bell-shaped curve. So in this kind of distribution, where we have the mean, the median, and the mode, they are all equal or very close in value. And we use this to identify trend also. We use that for inferential statistics when we want to do regression or hypothesis testing. Now, we also have the standard deviation, which measures how spread out data values are around the mean. Now, when we have a low standard deviation, it indicates that data points are closely clustered around the mean and it shows high consistency. But when we have high standard deviation, it indicates that the data is spread over a wider range and shows greater variability. So the standard deviation is useful because it is expressed in the same unit as the original data, and it measures that variability by quantifying the inconsistency. It also quantifies the volatility and the diversity within the set. So if we want to do like risk analysis in finance, high standard deviation means that the mean might be misleading, and so we use it to identify outliers also to do distribution analysis. We use it for inferential statistics. We use that for quality control, maybe like in a manufacturing company. We use that to identify if manufacturing measurements are within acceptable limits. And then we talk about regression models, where we try to understand and quantify the relationship between a dependent variable, which we call the outcome, and one or more independent variables, which we call the predictors. All right, we're going to look at this in machine learning, and when we do supervised learning and unsupervised learning, we're going to look at these different statistical models, but we use this to make predictions. We use it to explain relationships and impacts. We also use it to optimize processes, and in practice, regression helps businesses and researchers, and when we want to do sales forecast, risk analysis, and identify factors that affect quality and things like that. Okay? So in advertising, for instance, we can analyze how advertising influences sales or how square footage affects house prices and stuff like that. Now, regression analysis finds like the best fit or the best fit line or curve through a set of data points, and we're going to look at this when we do visualizations, where we want to see like a linear or a curve, and we'll see what the best fit line is, and it helps us to quantify how changes in predictors are associated with changes in response variable, and this will emphasize that whether the correlation implies causation and things like that. So we want to do outlier detection to start, and starting from this lesson into week 10, we're going to use the iris dataset, and which is publicly available, to see how we can do some statistical analysis, and then we're going to try to do some visualization. And as we go along, we might switch datasets to look for different datasets if we need to do that. So as always, you want to first of all pip install the packages you need. Now, what we're going to need in this lesson is Pandas, which we have already done. If you don't already have it, you pip install Pandas. We also need Numpy. You install your Numpy library. We're also going to use Scipy, and we'll use Scipy to get stats. We want to import stats from Scipy, and we also want to use scikit-learn. We want to get the data sets load iris from scikit-learn. So you install all of this, and I'm going to import Pandas as PD, then I will import Numpy as NP, then I'm going to say from Scipy import stats. We'll use this later, and then I'll also say from scikit-learn, from sklearn.dataset, I want to import load iris. There are several data sets in in this scikit-learn module, and we'll look at them as we go deeper. Now the iris dataset is loaded like this, so we'll use a variable iris, and then we'll load iris, and we want to load this as frame equal to true. And so we're going to look at df is equal to iris.frame, and then we'll print iris.frame, and then we'll print df.head. Let's run this to see if it works, and we have the head. So the head prints the first 5 rows of information. So now we can see the column sepal length cm, sepal width cm, petal length cm, petal width cm, and target. So these are the different columns that the iris dataset has. We want to do some basic statistical inspection. We're using Pandas to do this, and we use describe to do that. So let's say we want to print df dot, let's get the sepal length, so sepal length cm and dot describe. Now when we do this, we'll look for the mean versus the median, okay, and we have the mean here for 5.84, the standard deviation 0.82, the minimum value here is 4.3, the maximum is 7.9. Then we'll look at the different percentiles, 25th percentile 5.1, 50, 5.8, 75, 6.4. Now when we get to where we do visualization and box plot, I'm going to explain what these different percentile means for your understanding. But this is how we get some basic statistical inspection. For now, you might not really understand what each of these does, or how you can use this to get a feel of what the data distribution is like, right? But you can see the minimum value for that sepal length. You can see the maximum value. You know that we have 150 rows of information. That's the count. And we see the mean, the max, and we see the distribution of this if you have outliers. Now, when we want to detect outlier here, we use interquartile range, IQR, in Pandas. Now, the interquartile range is a measure of statistical dispersion. This statistical dispersion equal to the difference between the 75th percentile and the 25th percentile. And we use this to find the outlier by defining the boundaries, that is 1.5 times the interquartile range. Now, the interquartile range is commonly used to find outliers by defining these boundaries 1.5 times the IQR. Let's do this. Now, we have this iris dataset here. We want to get the first quartile. Let's save this as Q1. And we're trying to do this for the sepal length, right? So we'll say TF, we want to get that column, sepal length CM dot, we'll say dot quantile, and we want the 25th percentile. So we are doing this for the 75th and the 25th percentile. So we'll say 0.25, right? And then we'll do the same thing for quartile 2, will be the 75th percentile, and so we'll do Q2, and this will be 0.75. Now the interquartile range IQR will be calculated by saying the Q. So this is quartile 3, not 2, okay? It will be Q3 minus Q1, okay? And then that will be the interquartile range. Now we have to get the lower bound and the upper bounds of this, and the boundaries that we want to define is 1.5 times the IQR, right? So any IQR that we get, now we have this lower and upper boundaries that we use. So let's say call this lower. The lower is equal to the quartile 1 minus 1.5 times the IQR. This is the formula. And then the upper will be quartile 3 plus 1.5 times the IQR. And this is the formula we get to get the boundaries for it. Now, how do we identify these outliers? So let's say these outliers will now be equal to df. Let's have we'll have df sepal length, and this is in cm, less than lower, or df sepal length greater than up. So this is like how to get the outlier. So we just calculated formulas for this, and we use Pandas. It's easy to read. We work directly with the data frame, and when we do exploratory data analysis, it is easier with Pandas. So let's go deeper and look at how we can detect outlier using Numpy. For Numpy, we use a Z-score. Now, your last week's lesson resource has all of this calculation for different sample data sets, but we're going to use this for the iris data frame. So I'm going to remove this quartile or comment it out for now, and we're going to try to use Numpy to do this. So now let's say the sepal, let's call this sepal MP. We'll say this is equal to, we'll get TF. So the column name is sepal length in CM, and then we'll say for Numpy, we want to say dot to Numpy like this. Okay, so now this is the Numpy array. Now, if we want to calculate the Z scores manually, we'll do the mean is equal to np.mean sepal np, and we want to get the standard deviation will now be equal to np.standard deviation, and we'll pass in sepal np, and then the Z score is always the sepal np here minus the mean divided by the standard deviation. So Z scores is equal to sepal np minus mean divided by the standard deviation. And so this is how we do it manually. So you can print this. I don't think we really have outlier on this data set, but just for you to see. So you can print out Z scores like this. So we have it calculated like this. And so we'll look at how these values, statistically how we can use these values as we go along. So if you want to detect outliers with this, let's remove the print now. We are going to say, let's say all these Numpy outliers will now be equal to sepal np, and then in the pair of square brackets we want to say np.abs z scores like this, and we want to say this is greater than 3 here. So we can see that when we do Numpy manually, when we have large numerical data, this is faster. We have lower level control, and we don't have any data frame overhead for this. So we can print out Numpy outliers to see, and we'll look for another data set that really looks messy and dirty for us to clean up for you to see. So we don't have outliers, and so we see we have empty square brackets. We can also use Scipy that provides a built-in statistical method, and we can use that to compute Z scores also. Scipy, I'll delete this. We're not going to use Numpy. For Scipy, I will say Z scores. Let's say Z scores Scipy is equal to that, because we imported stats from Scipy, stats.z score, and we want to get a column df sepal length cm. Okay, and so to detect outlier now, we'll say let's call this Scipy outlier will now be equal to df and np.abs. In a pair of brackets, we'll have z scores Scipy is greater than 3, what we did previously. So Scipy here is statistically standardized, is cleaner and less error prone, and is preferred in scientific research. And so we have seen the 3 different ways we can detect outliers or calculate the outliers in Pandas, in Numpy, and using Scipy. You just choose one to do depending on what you use. And so for Pandas, we use the interquartile range method. For Numpy, we use the manual z-score method, where we calculate the mean, the standard deviation, and then we now use the calculation. And then in Scipy z-score, we use that one because it's cleaner, statistically correct. Numpy is high performance and flexible, while the interquartile range is best for skewed data and for exploratory data analysis. Alright, now to remove outlier in Pandas, let's remove outlier. We do have one, so let me comment this. I'll remove the comments back. So we have this interquartile range, and we did the lower part, and then we did the upper, and then we want to clean the data set. So let's say df clean, and we'll say this will now be equal to, we'll have the data frame, and now we want to pass in sepal. So let's do df sepal length cm is greater or equal to lower, and df sepal length cm is less than or equal to up. So this is going to get us the clean data set. So if we'll do df, let's print the shape of df, print df.shape, and then we'll print df clean the shape. Now I'll clear here and I'll run. So we have the same shape in both, because we actually do not have outliers for us to clean out in this, but we're going to explain this deeper as we do the visualization. Okay, we can use winsorization to cap the outliers, and for this you can use mp.clip. You can refer to your lesson resource to see how that is done. And then we can also do multi-column outlier detection using Pandas and Numpy. You can also look at your lesson resource, and we're also going to look at that in details in the live web conference, where we will look at multi-column outlier detection. So how do we know when to use what? For Pandas IQR, we use this for rewards data sets that has skewed distributions. For Numpy z-score, we use this when we have a performance critical pipeline and it assumes normal distribution, and also the Scipy z-score assumes normal distribution but used more in statistical and research grade analysis. And we will now look at how we can use a Boxplot to detect outlier and to be able to read. And this is for quick check for outlier. Boxplot is something that will come in handy for you to use. So now let's do a Boxplot here. I'll comment this out. For us to use a Boxplot, we need matplotlib, and so I'll say import matplotlib as clt, and then here I'm going to say df sepal length cm dot plot box. So you have to pip install matplotlib if you want to do your plots. Alright, so pip install matplotlib, and so I'll do this to plot the box, and then plt dot, I want to add a title, so plt dot title, let's put the title to the box plot. I'll say box plot of sepal length cm, and then let's add a read, plt dot read, and we want to put default. The grid should be true, and then we want to show. So plt.show, we want it to show. Now I've done this. Let's run this and see plots. Model title. So sorry, I did import matplotlib.pyplot. I didn't put that .pyplot as plt. So that's what we'll import and clear, and we run again, and it should plot this. And so now we have a box plot. So now you can see this box plot of the sepal length cm. Now we are going to look at the interpretation of this, and that will point out the whiskers for potential outliers. Now this box plot now gives us the summary distribution of the sepal length values in centimeter. We can see the title that we have. Now the bottom of the box, this is quartile 1, and we can see it's around 5.1, right? Q1 is around 5.1, and the top is quartile 3, and this is around 6.4, let's say around 6.4, and this is the 75th percentile also. Now, so most of the sepal length will fall between 5.1 cm and 6.4 cm according to this box plot. This is what it's showing us. Now the middle of the box shows the median. This middle line is the median, and we can see that this median line is around let's say 5.8, right? So the median is approximately 5.8. This means that half of the flowers have sepal length shorter than 5.8 cm. So that's like the middle number. Half of it have shorter than 5.8 cm, and half are longer than 5.8 cm. Now this whiskers that we have here is the minimum and maximum values. So we can see the minimum whisker here is on 4.3, that's the minimum value. Maximum is on 7.9 here, that's the maximum value. So this is how the box plot shows us that. Now we cannot see any visible outlier because there are no points outside the whiskers. So if you now find a thick line outside this whisker, then you have significant outlier. But now we can see that all the values fall within a reasonable range, and so we don't have those whiskers outside of this, right? So the upper whisker is slightly longer than the lower. If you look at this, we have more of them above the median and less below the median. Okay, so it just suggests that we have a slightly right skewed data, meaning some flowers are relatively larger sepal length or more flowers. Okay, so summarily to interpret this, most sepal lengths are between 5.1 and 6.4. We have the median sepal length is about 5.8 centimeter. It shows moderate variability. There are no extreme outliers here, so we don't have any thick line outside the whiskers, and the distribution is slightly skewed because the top is slightly longer than the bottom line, and is skewed towards the larger value, so it's right skewed. So the best practices for outlier detection is to always visualize before we remove data. We always want to use interquartile range for skewed data. We want to use z-score for normally distributed data, and you don't want to blindly just remove outliers, and you want to consider the business context or the domain context that you use. So the best use case for Boxplot is to quickly have a visual inspection of your data set. We use interquartile range when you have skewed data is the most common that we use, and then normally distributed data, you just use your z-score, and then the domain specific limit should be your threshold. In the next lesson, we are going to look at date time in details and how we can pass and manipulate dates and time in Pandas. Thank you, and see you in the next lesson.